convergent validity. Whether or not all the items that are measuring a particular construct converge to represent the underlying construct. This is the third step, that is convergent validity of each construct. Convergent validity is the extent to which the construct converges in order to explain the variance of its indicators, or in simpler terms, whether the indicators are representing the underlying construct or not. The metric or the measure that we use to establish convergent validity is called average variance extracted for all indicators on each construct. The AVE is defined as the grand mean value of the squared loadings of the indicators associated with the construct. So what we do is we simply take the square of each of the loadings that we did earlier and then sum the squared loadings. Now once the squared loadings are summed, they are divided by the number of indicators, and this will give us the average variance extracted for all the indicators on each construct. Now this has to be done separately for all the constructs in your study. Therefore, your AVE is equivalent to commonality of a construct. The minimum acceptable value is 0.50. An AVE of 0.50 or higher indicates the construct has the ability to explain 50% or more of its indicators' variance. Moving on. How do we see convergent validity? Now we simply run this command, and based on this command we will have AVE values for each of the constructs in the study. Now all of them are well over the required limit of 0.50. This means that convergent validity for all these constructs is established. This shows that the items are converging to measure the underlying construct. Since AVE is greater than 0.50, this means that the construct is capturing good enough variance of its indicators, and we can say that convergent validity is established.